In this lecture, we will examine how a message is prepared for transmission and how it is processed when received. This process is called encapsulation when sending and de-encapsulation when receiving. We will learn how each layer adds or removes information to help the message reach its destination.
Hi, I am Imran Afzal. I make learning technology easy, even for beginners in IT. So I have over 25 years of experience in Linux administration, Windows, virtualization, and many more. I have taught millions of students worldwide.
Let's begin with a basic scenario. A user opens a web browser and requests a web page. The browser creates a message that needs to be sent to a web server. This message passes through the layers of the TCP/IP model. At each layer, specific information is added to help with delivery, routing, and error checking. This added information is called a header. In some cases, a trailer is also added. The message becomes a structured unit of data that can be transmitted across the network. So, at the application layer, the browser generates the request. This is the original data without any networking headers. It is passed to the transport layer where the TCP protocol adds a header. This header includes source and destination port numbers, sequence numbers, and control flags. The result is called a segment. The segment helps the receiving device understand how to reassemble the data and which application should handle it. Next, the segment is passed to the internet layer. Here, the IP protocol adds another header. This header includes source and destination IP addresses and other routing information. The result is called a packet. The packet allows the message to be forwarded across multiple networks. For now, understand that IP addresses help identify devices across different networks. The packet is then passed to the network access layer. This layer prepares the packet for transmission on the local network. It adds a header and a trailer to create a frame. The header includes source and destination MAC addresses, which identify devices on the same local network. The trailer includes a frame check sequence, which helps detect errors during transmission. Finally, the frame is passed to the physical layer, where it is converted into bits. These bits are transmitted as electrical signals or wireless signals, depending on the medium. The message is now ready to travel across the network. As the frame moves through the network, it may pass through switches and routers. A switch reads the destination MAC address and forwards the frame to the correct device within the local network. A router reads the IP packet and decides how to forward it to the next network. At each router, the frame is removed and replaced, but the packet remains mostly unchanged. This continues until the packet reaches the destination network. When the packet arrives at the destination device, the process is reversed. The network access layer removes the frame header and trailer. The internet layer removes the IP header. The transport layer removes the TCP header. Finally, the application layer receives the original data and processes the request. Each layer in the TCP/IP model uses a specific name for the data unit it handles. At the application layer, the data is simply called data. At the transport layer, it becomes a segment when using TCP or a datagram when using UDP. At the internet layer, it is referred to as a packet. At the network access layer, it is called a frame. And at the physical layer, it is represented as bits. These names help identify where a problem might occur during transmission. For example, if a frame is dropped but the packet is intact, the issue is likely at the network access layer. To summarize, encapsulation is the process of adding headers and trailers to data as it moves down the layers for transmission. De-encapsulation is the process of removing those headers and trailers as the data moves up the layers at the receiving end. This structured approach ensures that data is delivered accurately and efficiently across networks.
I hope you learned something useful in this video, and I will see you in the next one. But please wait. Don't forget to subscribe.